All right, in Calculus, Chapter 4, Section 1, we're going to learn the antiderivatives today. That means the reverse of the derivatives, basically, is what we're going to do. So if I was to ask you the derivative of what is 2x, I want you to think about for a second. Now, we've done derivatives, so you're trying to figure out the derivative of what would equal 2x. Now, most students would tell me that would be x squared, because you would take that 2 to the front, and then times, drop that 1, and that would be 2x. But the problem is, what if you took the derivative of x squared plus 1? See, that would also be 2x. What if you took the derivative of x squared minus 5? See, that would also be 2x. So really, when we ask you the derivative of what is 2x, we really need to write x squared plus, and they almost always use a capital C in most calculus books. If I asked you the derivative of what is 2, hopefully you think 2x. But again, it could have been 2x plus 1. That could be 2x minus 5. All three of these have a derivative of 2. So in reality, 2x plus c would also have a derivative of 2 as well. So if I asked you the derivative of what is the sine of theta? So the derivative of cosine is a negative sign. So the derivative of what would be positive sine? And that would be a negative cosine of theta. And again, I could add a 1 or a 5 or a 7, any constant at the end. So therefore, it would be negative cosine theta plus c. And if I asked you the derivative of what is 4x to the third? Basically, remember when you took derivatives, you multiplied, and then you dropped this one, right? In that order, you multiplied, then dropped it 1. Well, when you do the reverse for the derivatives, you are going to reverse, so you're going to add 1, and then you're going to divide instead of multiply. Meaning I'm going to add 1 to that exponent, so it would be 4, and divide by the new exponent of 4. Therefore, that would be x to the fourth. See, think about that. If I took its derivative, it's going to be 4x to the third. Again, you multiply and drop 1. So in the antiderivative, you're going to add 1 and then divide. So if I add 1 to that, that's 4, and divide by 4. That would give me x to the fourth. And again, that could be a plus 1, a minus 5, whatever. Therefore, I'm going to put a plus c on there. So find the general solution of the form where the derivative, that means the y prime right there, equals 2. See, the derivative of what functions is 2? So that'd be 2x plus c. See, this derivative is 2, and then if any constant would be 0, so 2x plus c. And these are some different pictures. If c was negative 1, if the c was 0, if the c was 2, they're just showing you some different pictures where the derivative is equal to 2, meaning where all the slopes are 2. So find the antiderivative of 3 to the x. So remember a minute ago I said we will add 1 to our exponent and divide by the new exponent. So if this is a 1 and I add 1 to it, that'll be a 2 and divide by the new exponent. So it'd be 3/2 x squared. You can check it by taking the derivative of it. So 2 times 3/2, that would be 3. Drop it 1. There's the 3x. Derivative of the constant is 0. So again, the exponent was a 1. Add 1 to it, it's 2, divide by the new exponent of 2. That's where the 3/2 came from. So I want to find the integral of 2 of sine of x. So antiderivative, integral, either way, the reverse of the derivative. Now we know the derivative of the cosine is negative sine. So the derivative of the negative cosine would be positive sine. And that just happens to be a coefficient. So we're just going to have 2 times the negative cosine, therefore it's negative 2 cosine of x, and again plus a constant, because derivative of all constants is 0. So this is the integral symbol. This is for your antiderivative, and this is for integration. So we're going to add 1 to that exponent. That becomes 5, and then divide by 5. We're going to add 1 to this exponent, 3, and then divide by 3. Add 1 to that exponent, so this is x to the 1, so it'll become x to the 2, and then divide by 2. And then the plus c at the end. Because if you take the derivative of each of these, this 5 would bounce to the front, and it reduces with that one, and drop it 1. It goes right back to this. Again, the 3 would go to the front times, well, those 3's divide, and drop it 1. Perfect. Again, the 2 to the front, they reduce, drop it 1, x to the first. And derivative of any constant is 0. So this right now has an exponent of 1, so if I add 1 to it, it's going to be 2, and divide by the new one of 2. This has x to the 0, so add 1 to it, that would be 1, divide by 1. And and derivative of any constant would be 0. So what if I asked you just to integrate d of x? Most students go, what are you saying? You're missing the problem here. No, we're really not. That really means you're integrating 1 times dx. That means I want to know what type of graphs would have a slope of 1. Well, that would be any line with a slope of 1, meaning 1x plus c. So again, this is x to the 0. Actually, 1 is any x to the 0. So if I have x to the 0 and I add 1 to it, it's x to the first divided by that 1. That's your x. Derivative of any constant is 0. So sometimes we have to take our original integration, we have to rewrite it, integrate it, and then simplify. Kind of like what we did with derivatives earlier in the year. So again, we want to do our rewrite as that's going to be x to the 1/2. Add 1 to that, so it would be 3/2 divided by 3/2. Now we can't leave that as our final answer. That's a fraction right here within this fraction. So if I multiply top and bottom by 2, or think about dividing by fractions, easy as pie, flip that 3/2 right there and multiply. So flip the 3/2 we mean times by 2/3. So therefore it'd be 2x to the 3/2 over 3. Right, integrate 1 over x to the 3rd. So you want to rewrite it first. So I need to bring that up. So that would be x to the -3. Add 1 to -3. Adding 1, think about on a number line, adding 1, you're going to the right one. That means you're going to -2. And then divide by that new exponent. Now this exponent can't stay negative in my final answer, so it would have to come down. So therefore we're going to have a negative, then 1/2, and the x squared's on the bottom, then plus c. So if this was my problem, every time my denominator is a monomial, when this is a monomial with an x, we should rewrite it by dividing it into each term. Now this is x to the 1 divided by x to the 1/2. That would become x to the 1/2, 1 minus 1/2. Then I have 1 over the square root of x, and that's where I got x to the -1/2. When you add 1 to 1/2, you get 3/2. When you add to -1/2, you get positive 1/2. There's the positive 1/2, there's the 3/2. So we're dividing by this 3/2 right here. So therefore this would be 2x to the 3/2 over 3. This one would be 2x to the 1/2. And then it's plus c. So don't forget that the derivative of the sine is cosine. The derivative of the cosine is negative sine. Derivative of the tangent was secant squared, and so forth. So when you're talking about the reverse of them, so the integral of the cosine would be sine, because you're going backwards. The integral of the sine, if there's the integral of that, that would be the negative cosine. The integral of secant squared is tangent. Integral of secant, tangent, secant, integral, and integral. These are going to need to be memorized. Those are going to be new on your Quizlet for Chapter 4. So we want to integrate the sine over the cosine squared. Now I do know if I break that up as sine over cosine times 1 over cosine. The sine over cosine happens to be the tangent, and 1 over cosine happens to be, hopefully you were thinking the secant. See, now I can integrate the tangent secant. The derivative of what is tangent secant? Well, that would be the derivative of the secant. And then again, don't forget your plus c's at the end. On the open response part of your test, some people tend to leave these off, and you're going to end up with points off if you do so. It says solve the differential equation with the initial condition f of 2 equals 4. So first this just means to just integrate where we have a plus c. But because they gave me a point that the function passes through, we're going to be able to find the value of c this time. So first we integrate. Add 1 to this exponent, so it'd be 3, and divide by 3. So there's adding 1 and dividing by it. That was right there was negative 1x to the 0. So when I add 1 to it, it's x to the first divided by 1, and then again a plus c. Now these 3's reduce. Now remember, this would be just plain integration, but the problem is, as I'm told, at the initial point that the graph goes through, that means I have an initial condition. So when x is 2, the y equals 4. So therefore, this is telling me that when f of 2, it equals 4. So plugging in 2 for the x's, 2 cubed minus 2 plus c, because I don't know c, equals 4. There's 8 minus 2 is 6. Move the 6 over, my c is negative 2. So therefore, my final answer would be y equals, or f of x equals, x cubed minus x plus the c, which was negative 2. There's our final answer. So again, you just integrate like normal. You add 1 and divide. You add 1 to the exponent, divide, your plus c. But you have to plug in this x value to equal to this y value so you can find the value of c, to get your final answer. Again, it was another one, find the general solution. So we're given that if I'm given the derivative as 1 over x squared, then that means I need to integrate this to go back to the function, and I'm told the f of 1 equals 0. So I want to rewrite this first as x to the negative 2. Add 1 to that, that would be negative 1. Divide by the negative 1. So that gets rewritten as negative 1 over x. So this is the general solution. So find the general solution means a plus c. Now, finding a particular solution means when you plug in the x, in this case is 1, the equation equals 0. So we plug in 1 for x. The equation is equal to 0. Now, plugging in 1, that'd be negative 1 divided by 1. So that was negative 1. Add it over, c equals positive 1. So the particular solution, I'm going to plug this 1 in for the c, and there's the particular solution. Okay, and this is just a different picture of what it looks like with all the different c values. All right, that wraps up lesson 4.1. I wish you guys the best of luck. I'll see you tomorrow.